Hello and welcome back. Right, so we have the bottom half of the engine casings, or part of the engine casings, and in this is the water jacket and the exhaust, and I have a broken off stud here, and this one I had started drilling, and I thought before I take the threads out I'll try and put a stud extractor in there. So I got one of these fancy Torx stud extractors, knocked it in, and the thing snapped. So now I have a snapped off Torx stud extractor in that bolt, hardened, and I've got two others, but also in the other end I've got a snapped off stud there in the top of the cylinder. Being a two-stroke, this doesn't have a cylinder head as such. This is the water jacket, and that one there is so corroded I couldn't get it out. Heat, nothing shifted it, eventually it snapped. So we're going to have to take these out, and to do that I'm going to have to make a plate on the lathe. I'm going to use this big slab of steel, it's 13mm thick, and we're going to cut it to a square, drill 4 holes in it for the mountings on here. So I'm going to try mounting it in these 4 holes. They're about 70 something mils across square, so we'll mount it like that on there. But also I've got to drill some holes in this to mount it to the lathe, which is over here. Now you can see I've got the cross slide set up on the lathe, so we're going to mount it here on the cross slide. So I've got a vertical slide there as well. This goes up and down, and this will give us the ability to line it up with the chuck and see if we can drill these out, because it's the most accurate way I have of drilling something. The drill press is okay, but holding it might be an issue. Now the first thing I've got to do is turn this metal plate into a piece the right size, so I'm going to cut down here roughly, and then sort it out later, trim it up. But to cut it I'm using this plasma cutter. Now I bought this not very long ago for a job, and to say I'm disappointed with it would be an understatement. It came with a 13 amp plug for a start, which okay in itself isn't a problem, but in the 13 amp plug were these. So that's in a 13 amp plug. Now why they didn't fit a 16 amp blue 3-pin plug to it, I don't know. On the advert it was displayed as having one of these, so I had one of these fitted in the workshop, one of these proper 16 amp plugs, and the unit said it came with one of them. In the photo it was displayed with one, said it had it, and then it turns up and it's got a 13 amp plug on it, so I don't know if it's going to cut this, but we'll have a try on the end first and see if it trips out. Okay, so I think we'll just have a quick trial run first and see what happens, and see if it will cut this plate. I've got it set to as much as I can set it without it blowing the electrics, and yeah, let's see what happens, see if it will cut this plate. It seems to be doing it. It seems to be going through, so I think I'll carry on. Right, so we need to mount this on the lathe. Now if the chuck's here and the carriage is sliding like that, this is the vertical slide here, we need to mount this on the vertical slide like that. So I need to measure these 4 hole centres. And the best way to do that is put a bolt in each one, like so. And measure across. These calipers I think are on the way out. I need to get some more. 70.82, and the same across this side as well. Put one in here and we'll double check that. 70.89. Okay, so we've got a 70.89 square, and what we need to do is minus the thickness of a bolt. So we'll measure a bolt, 6 millimeters effectively. 70.89 minus 6 will give us the center of those bolt holes. Okay, so now we've decided to use a different set of holes. We'll measure those again and see what they come out at. $102.87. Write that down. 102.87. Now, just to make sure that my calipers aren't dying or misbehaving, yeah, so we'll just open them up again, take the measurement again. I like to take a measurement at least twice. Yeah, spot on. So 102.87. Now that we know the dimensions of our hole centers, the distance between centers, we need to start dividing up this plate. Now, the cross slide is 135 millimeters high, and that is 126.7, so that's fine. So it's also 69.5 millimeters wide. So I also need to make it wide enough to accommodate this, so it needs to be wider than this. So we need to cut a width that is, what's that? If I said 125 mil, that would leave us a little bit of room. So I need to mark 125 mil in from this edge square down here. So let's get a pencil. 125 mil. This doesn't have to be super accurate width, but somewhere close is good because it's only a rough dimension for the fixture plate. The next bit is the bit that has to be accurate, so we'll mark that there. We'll get the square, move this out of the way, move them out of the way so I don't squash them. Put the square up there. Now I know that edge is straight, so I can just mark straight down here. Okay, we have ourselves a line. Now, let's go and attempt to cut that, shall we? Now, I've set up a bit of a fence for my plasma cutter to run down. It's not super accurate, but we're going to be working off one baseline anyway, and the whole thing's adjustable. So this is just a basic fixture plate, a mounting plate if you like. The only thing that has to be accurate are the 4 holes that we're going to drill. So I'm just going to cut this out and see if it cuts through without blowing all the electrics. It's really not worked very well at all. It's just ruined the material, and that was the only piece of thick plate I had, so this is about knackered, but I'm going to see if I can rescue it. Okay, so we have our piece of plate. I think we found the limits of the plasma cutter. It wasn't a very nice cut, but it did it in the end. Now, this plate is going to be mounted on the vertical slide like that. So the vertical slide is going to be here, the plate's going to be mounted up against it there. So, let's mark this up then. This is the top, and that's outer face. Okay, so we know where we are now. Now this has to go on the vertical slide, and then this has to mount to it like that. So we need to find the center of this piece of steel. Let's see, 126. If I say 125, it's close enough, because we're not needing millimeter perfect accuracy. So we need a line down the middle, 62.5 millimeters. So let's just do that now. Set my calipers to about 62.5. Just has to be roughly, let's just move that out of the way whilst I mark this, roughly central. So we'll just mark that now. Not the best use of calipers, but it does the trick. And we have a nice line straight down the middle of that. Now, we also need a line across here, roughly not quite the middle. So let's make it about there. So if I mark that now, get me a pencil. Put me square across there and across there. So I know that's square there. And I know that's a square side as well. We're just not going to use this side for measuring anything because that's the side we cut and I haven't bothered doing anything to it. So that is the centre point of where we're measuring from. So we need to mark 2 holes on here, exactly 96.87 millimeters apart, bang smack equidistant from that line. Okay, let's centre pop these now. One. Two. Just check they're relatively on point. 1, 2. It's slightly out, but it's not going to cause us any major biggies. Right, now we'll drill them to accept a 6mm bolt with clearance. Now the way I centralise things in the drill is I have a little pointer which is dead centre, and I line everything up so it just sits in the divot of the centre pot mark. Then I can put the drill bit in and know I'm drilling in exactly the right spot. Right, so now we can drill this out. Sorry about the bad camera work. A tip when drilling, if the swarf gets too long, just back off and it breaks away. So you don't end up with these huge, great annoying clumps of swarf whipping your hands. One hole drilled. Now just the other one to do. See, that's why you should peck at your holes rather than let the big swarf build up. And both those screws line up perfectly with that there. I could just slide them in perfectly, in they went. So now we have to drill the holes that are going to line up with the vertical slide. So to work out where to drill the hole on the vertical slide, we're going to measure from the top of this down to the base plate on the cross slide, and then subtract half the distance of this bolt, or the thickness of this bolt, and mark a line right the way across. Okay, let's measure the distance from the top of this bolt down to the cross slide. Now I'm working that out at 67.87. Now we'll go and mark that on our piece of metal minus the diameter of this bolt, and the bolt itself is just over 9.5 millimeters. This is an imperial lathe, but those are metric bolts, so I've measured it in metric. So we'll minus about 4.75 mil or whatever it is off each side. Now I've decided to leave a few millimeters of gap between the bottom of the plate and the cross slide, so I've got a bit of wiggle room to make sure I can get this trammed in square. So I'm going to do it at 65mm from this line, and we'll just mark that there. Okay, we'll come in with our square and we'll mark that line right across, like that. So we now have 2 lines, and we want to measure 1 inch out, because the cross slide is 3 inches across, and we don't want to be right on the edge of the cross slide, so we need 1 inch from each side. But we can do that by hand. That doesn't have to be super accurate, because it is just a securing bolt in a slot. So we'll just mark that one there, and mark this one here. And as long as they end up in the slot, we're okay. So I'll now centre pop those, and drill those holes out as well. There we go, centre popped, and I'll go and drill those. Right, so what we'll do with this is pilot drill them first, because I'm going to have to drill at least a 10mm hole. So I started with a 6mm bit, centre popped and marked. Sorry about the crappy camera. And we'll just drill this out. And just like that, we have a 10mm hole. Okay, so that is the plate mounted to the cross slide, and we'll just see if we can get the engine casing to mount on that successfully. So now we need to see if the engine casing will fit over these studs and line up with the holes. Well, it's gone over the studs. Okay, so I've got the casing mounted on this plate, and I've just locked it in place with lock nuts and little set screws. And this is how I make sure it's parallel. I know this chuck is exactly parallel to the bedways. Oops, let me get that out of the way. So I put a piece of parallel steel in there, piece of tool steel, and I ride it up to the chuck loose on the carriage, so it's not bolted down, until it is exactly butted up against that, and then I cinch down the 2 nuts and check it again. So we know that it's parallel in this plane, and we know that it's parallel in this plane, and we know that it's, well, we hope that it's horizontal in this plane, because that can't be changed now, really. I'm going to check it with an indicator across this top piece, but I suspect it is, because we drilled these holes exactly parallel with the base of the plate. The base of the plate is exactly parallel with the cross slide, which is flat. So this is why I put the rough end down this side, because I'm not using that as a measurement, obviously. So we took all our measurements off the bottom, and I double checked they were parallel with the bottom. The bottom is butted up against the cross slide, and that's all cinched down. This is all bolted down nicely, so hopefully we have a straight and true drilling to do on this bottom bolt. So I'll slide the carriage out of the way, and you can see that I've got that one there to do, just there. And we'll start with that one and see how we go. Okay, now I've switched to a collet chuck and a 4.5mm drill bit. I'm going to try and take the centre out of this bolt. Not really expecting a lot. It is a cobalt bit, so it is hard. We'll see how it goes. Not expecting it to work fantastically, but we'll give it a try. We'll just peck at it slowly. No. All I'm doing is knocking that out of true. I'll have to tighten that up and check it again. Okay, so I've tightened it down again, checked it all it's all level, and we'll give it another shot. I'll try it with a higher speed. This is cobalt after all. Nothing. It's not even marked the inside of that, so I don't know what I'm going to do there. Maybe mill it out. That might be the next course of action. Get a mill bit in there and mill it out. Okay, so I've switched to an end mill, and we'll see if I can't get this out of here, because the drill bit just didn't cut the mustard. Okay, here we go. Oh, we're making some progress now. I can see shavings. Don't know how successful it's going to be, but it's doing something. Let's have a look, shall we? It's definitely cutting away at it, so we'll just carry on like this. I've switched over to a much smaller bit to try and get the centre out of this. So we'll give that a go and see if, I think it'll break, but we'll give it a go anyway. Let's see what happens, eh? I don't think that's doing an awful lot. I'm not having much success with that. I had more luck with the larger end mill, but I've got to get that hardened centre out first somehow. Okay, I remembered I had these carbide tipped drill bits. They're not the best, and I bought them from a show a long time ago under the claim that they'll drill anything, which I don't think's true. But we'll give it a go because I'm running out of options. As you can see, it's not even central. No, nothing at all is even touching that. That is a little tit on the end of that, and all I've done is, with the wandering of the drill bit, it's scoured away the top. I'm thinking maybe the only way to get this out is get it spark eroded, but I don't want to do that. That costs £100 a hole, and it's expensive, so I'm going to avoid doing that. I might even chop the end of this off and rebuild the casting in Belzona, because I know that's strong enough. But I really don't want to. I don't want to have that spark eroded. Okay, if plan A fails, we still have plans B to Z. This is a diamond grinding bit / drill bit, and I've got it in a micro chuck in a collet. Not the best, but it's what I've got to do to make it work. Now these should really be lubricated with water, so I'm going to try and somehow get some water spray on them. I don't want to get any oil on it, it seems to clog them up, so I think this should do the job. I'm hoping it does, because if it doesn't, spark eroding is the only answer, and I don't want to do that. So I'll set this up, find some way of lubricating it, and I'll carry on. Okay, let's see what this does. I've got a little bit of water here for lubricating it with, and we'll see what happens. I'm not holding out much hope. I don't think it's going anywhere near fast enough. Try it on flat out speed. As far as I can tell, that's doing absolutely nothing. I was hoping it would grind it away a bit, but it's not done anything. I think spark eroding might be the only way. I'm loath to pay for that because I'm tight, but there we go. I'll see if I've got any more of these diamond bits that might do the job, or a glass cutting diamond bit that's a ring that would cut the edge, because I think what's happening is this isn't moving fast enough in the middle to be able to cut the edge of, cut round it, so the middle is not grinding away. and I think that might be the problem. So if I had a small ring-shaped piece, like a hollow drill, like a hollow diamond drill might work, but that's not even marked it, so I think we'll have to come up with a different plan. Okay, so I've switched to a very high quality brazed carbide bit in the hope that it'll break through the hardened bit of the bolt remover. So we'll give this a go and see if it works. I'm not holding out much hope. I have got two other options if this doesn't work. So look and see if it's doing anything. You know, I think it is. I think that's working. So we'll just keep proceeding like this, very gently. Actually, I think it's pushing the drill bit into the collet. But I think it has dimpled it slightly, so we're on a winner. I think it's just a case of keep the thing going. I'll tighten it as much as I dare. Oh, no. Tighten that up a bit. And away we go. Spinning nice and fast. See if we can't drill this out of here. Because the hardest part is breaking the tip through. Once the tip's gone through, it'll become a bit easier. I think we might be making some progress, but I'm not sure. No, not making much progress at all. And in fact, we've taken the edge right off that carbide bit. Not snapped, just worn away, I think. So that's a non-contender. On to option number, I don't know how many, but we're on to some serious options now, so we'll have another go. Right, my next piece is a glass bit, which is very pointed, and hopefully, looking at the tip, I can get that in focus. It should break through, but I'm not holding out any hope. This is for drilling glass. It's a carbide bit, and the problem with glass is the surface is so hard, it's very difficult to break through without shattering the glass. So we'll have another go and see what we can achieve. I'm not holding out much hope for this either, but you never know. It seems to be making a lot of noise, so it must be doing something. And we are getting shavings up here at the bottom. I think we might be onto something here. Yeah, it's drilling. Very slowly, but it's drilling. And carbide likes a nice even load. It doesn't like to be bumped or loaded then unloaded, loaded then unloaded. So I'm just going to feed this very gently into the bit. And yeah, we definitely got into the middle of it now. We'll have a stop and look and see what it's like. That's started drilling, so I'm going to keep going with this for a bit and see how we proceed. There's always a way. No matter what happens, there's always a way. And the trick is not to use your last attempt as your first attempt, because then you've taken away your ability to do anything else. So you must always use the least destructive method first. I think we've cracked it. I think we're well on the way to drilling that out, and I've just snapped the tip off it, so that is now scrap. I don't think that's going to do us any more favours, so we've lost an option. Okay, so I've decided to move on to a diamond core bit. These are designed for drilling ceramics, among other things, so we'll have a go. They don't like to be run dry at all. They really don't like it. I don't like using a water on my lathe as a coolant, but I'm going to have to, so we'll see how this goes. I've got to use a slower speed. They don't like running too fast, so we'll slow it down a bit. Let's see what happens. Make a decision based on what's happening. I think it's doing something, so we'll see. slowly grinding away at the substance that's there. I think it is going in slowly. It's grinding away at something. It's just going to be a very slow process. You've got to keep it cool, and I'm going to put some rag there to soak up the majority of the moisture. I really don't want my lathe getting soaking wet. I'll go over it with emulsifying oil later. Well, I think we're making some progress. I can see it disappearing into the past. Yeah, we're getting swarf out of there, so it must be doing something. But yeah, I think we've cured it now. We're making progress. The trick is not to push too hard. Because it's hollow, it doesn't matter about starting, it just grinds its way through. And these super hard substances need to be ground away. So that's what I've resorted to, grinding it away. It's going to be a very slow process, but the trick is keep it clean. Don't let the aluminium build up, because what the aluminium does, it blocks between the grit, and then the grit doesn't cut then. I'll show you what it's like. Effectively what we're doing is grinding away. So I'll proceed with this, and I'll show you when I've done it, because I'm going to be here a while. Now this is working really well. We are proceeding slowly, but we are proceeding. And the bit, if I can get it in focus, let's try, there we go. It's a split bit, so there is a crack in it to help remove the swarf. It's diamond coated, 6mm across, and it doesn't seem to be struggling at all. And it should be hollow all the way up here, so we'll find out how hollow it is, as depends how far we can go. Well, I just heard a crunch, so I'll stop drilling, and I think if I just give this a quick clean. There we are. I think if we look in that hole, there we are, the centre's gone, the hardened centre's fallen out, and it's probably somewhere up the top of that drill bit, because that's a hollow drill bit. So there we are, project saved. We can drill that now with a normal sized drill bit and put a helicoil in there, and that's the thread sorted. So there we are. That is why you have plans B to Z after plan A fails. You must have a plan for if your backup plan fails, and a plan for if that backup plan fails, and each one's slightly more destructive than the previous method. You always start with the least destructive method and end with the one that's going to leave you with no way back. And that's what we did, and this method worked. Diamond core drill bit. Now we've got the hole drilled out, we can start tapping for the helicoil. Now this is an M6 helicoil, so it's a funny size. You have to buy the kit, otherwise you probably won't get this. It's a 6.2mm drill bit, and the tap is an odd one. I'm not entirely sure what the tap is, but it's specifically designed for this helicoil kit, so we'll use it and see where we get to. And that's the job all helicoiled and repaired. Now just two more to do.